Hi everyone, this is question 38, 39, and 40. The question says, the table shows how long 15 customers waited on hold before speaking to a customer service representative. And the customers are listed on the left side of the chart, and the wait time, how long they had to wait, is on the right. And you can see it ranges from the shortest wait time, 3 minutes, to the longest wait time, 55 minutes. So the questions say, identify the statistical questions based on the table data. Did customer 6 wait for more than 10 minutes? Second question, how many customers waited on hold before speaking to a representative? Question 3, which group had a higher typical wait time? Customers 1 to 5 or customers 6 through 10? And then the last two, I kind of grouped them together because the first question says, what was the average wait time for the group of customers? And so to find the average, again, we were doing this before we left for the end of the school year. We were adding up the numbers. So you would add up the wait time and then divide by how many numbers you added up to come up with your average wait time. So I'm not sure what that difference of an answer would be for the last one. How long did each customer wait to speak to a representative? So each customer waited different amount of times. So I'm not sure if that is the answer there, that each customer waited different time lengths, or if they want the average amount. So either one will work for the last, but definitely for question 4 here, you should find the average, and you may use the calculator to do that. For question 39, I'm trying to find it on mine. Okay, it says below are the 25 birth weights in ounces of all Labrador Retriever puppies born at Kingston Kennels in the last 6 months. And so they're all listed there for you. Each number represents the birth weight of a puppy. All right, they're in order, which is great. The first one says use an appropriate graph to summarize these birth weights. And so, just looking at the number, the first thought I had was to make a line plot. It is totally up to you which ones you would like to do. But just to give you representation here, you would start with 13, next number is 14, 15, and so forth. And then there's 113. And so there is 114, but there's 2 15s. So that's a line plot. You could draw a bar graph. You could draw whatever type of graph best suits what you think this data could be represented by. I just think the line plots are super easy. The second part of this question, you will need to finish the first. The second part of this question says, describe the distribution of birth weights for puppies born at Kingston Kennels in the last 6 months. Be sure to describe shape, center, and variability. So once you get a line plot, it's really easy to look at the shape of the data. But some of the questions that you can ask yourself for this one to answer it. What was the most birth weight? Or where was the most birth weights clustered together, like grouped together? Maybe the range in birth rates you could tell. Maybe the middle birth weight or the median birth weight. That can help you describe the shape, center, and variability. The center would, of course, be the median. The last question says, what is a typical birth weight for puppies born at Kingston Kennels in the last 6 months? Explain why you chose this value. Typical can mean a lot of things. I think when we talk about what is typical, we think about what is most common, where most of the data lies. So look at your data once you have displayed it on the line plot or whatever graph that you choose to do, and that will help you. The last one, number 40, says Mia predicted that she would score at least 90% on 8 of her 10 math quizzes. Look at the chart. Was her prediction correct? Okay, do you see a chart? I do not. I'm pretty sure School Corporation left this chart out of our packet. So we are going to X that one out. And that is all for this video.